Lesson 1.12, Horizontal Asymptotes with Analytic Limits. You're being asked to find if a function has horizontal asymptotes without graphing. And to be able to do that, you need to know what's happening when it goes to the right forever and what's happening when it goes to the left forever. Does it ever flatten out and reach a horizontal asymptote? So you're really finding a limit as x goes to positive infinity and as x goes to negative infinity. A function could have one, two, or no horizontal asymptotes. So let's just jump right in. This ties into what the last lesson was, is how do I find a limit to infinity? Well, in a polynomial, I just need to pick the biggest powered term I see, which is 3x to the fourth. So I'm going to be doing the limit as x goes to positive infinity of 3x to the fourth and the limit as x goes to negative infinity of 3x to the fourth. Okay, remember we're plugging in the word big, so it would be equal to 3 times a big number to the fourth power. That would be big, and it would all be positive, so that would go to positive infinity, which in our language, if it's not an actual value, then that does not mean there's a horizontal asymptote. That means that as we're going to the right, this end behavior is going up forever, which means it never will reach an asymptote. All right, for the other one, we'll have 3 times a negative big number to the fourth power. That would get a positive as well, so 3 times a big number to the fourth will still be a big number. So this one has no horizontal asymptotes, or none. Okay, number 2 has the square roots. Honestly, these are my least favorite, but they're not too bad. We need to pick out the highest degree term on top and bottom. So top, it would be the 9x to the sixth all under square root over 6x cubed. We're going to find the limit as x goes to infinity and the limit as x goes to negative infinity. All right, so I would have the square root of 9 times a really big number to the sixth over 6 times a really big number cubed. That would all be positive. So all I'm doing is square rooting, and I get square root of 9 is 3, and I would have a big number cubed over 6 times a big number cubed. Those would be the same value, so they cancel. 3 6 reduces down to a half. There's my numerical value, so I know there's a horizontal asymptote at y equals a half. There's at least one of them. Let's see if there's another one. This time I'm going to plug in a really, really big negative number. So I have square root of 9 times negative big number to the sixth over 6 times a negative big number cubed. This would become a positive, so all I have to do is take square root of 9, be 3 big cubed. Negative to the third power is negative, so this would be negative 6 big cubed. Cancel, cancel, negative 3 6 reduces down to negative a half, so there's 2 of them, and at y equals negative 1/2. All right, number 3, we have a rational function with e. Remember, e trumps any kind of powers. So we've got this and we've got this in the denominator. Let's find the limit as x goes to infinity of negative e to the negative x power over 5x cubed, and the limit as x goes to negative infinity of negative e to the negative x power over 5x cubed. All right, so I'm putting in a positive big number, so that would be negative e, but it's a negative in front, so a negative big number over 5x cubed. Remember, if we have a negative power, it needs to sink to the bottom, but I keep the 1 on top. So it'd be a negative 1 over 5x cubed times e to a really big number. So all my big things are happening on bottom. When we have something small dividing by something big, that approaches 0. Positive negatives don't matter. So I do have a horizontal asymptote at 0. And then this one, would have negative e to a negative of a negative number, so then that'll become just a positive big number over 5 times a negative big number cubed. So that will stay negative e to the big number on top. The denominator is going to be a negative 5 big cubed. All right, let's see which is bigger, or which grows the fastest. Would be this exponential function would win. And when the exponential function wins, when we have a top thing divided by a smaller bottom thing, then that is going to be an infinity, and we have a negative divided by negative, so that's positive infinity. So that is the same as our rules. Remember, to finding horizontal asymptotes of rational functions, when the top degree is higher than the bottom, then it does not exist because it really has a slant asymptote. So we only have one horizontal asymptote at y equals 0. Okay, number 4. This is where you're multiplying things. You pick the biggest piece out of this binomial, but then you'll have to multiply times e to the x. I'm going to go ahead and plug in big. This one's pretty easy to see that if I have a big number squared times 2, that's big, times even bigger, and that's big. So that will be no horizontal asymptote. Okay, I'm going to have to fix this and drop my e to the big on the bottom. And then that'll be squared, so it's positive. So I get positive 2 big squared over e to the big. My denominator is bigger this time, so when the denominator power is higher, it automatically goes to 0. I have something smaller divided by something really, really big. So we have a horizontal asymptote at y equals 0. And last one, this 3 obviously is not going to have any impact since it has no infinity or anything with it to be plugged in. The only part we're worried about is this. So my limit as x goes to infinity would be 2 times e to the 1 over a really big number. 1 divided by something really big. So like 1 divided by 1,000, you should know is 1,000th. It gets really, really, really small. It's going to keep getting, right, closer and closer to 0. That's scientific notation. You're going to have 8 zeros before the 1. Okay, so then this means this is approaching 0. What happens when we have something to a 0 power? That is really 1. So it's 2 times 1 would be 2. All right, and our limit as x approaches negative infinity of 2e to the 1 over a negative big number. Again, 1 divided by something really, really big becomes 0. So that's 2e to the 0 power. That's 2 times 1 again, which is 2. So you only have one horizontal asymptote at y equals 2.